Isaiah Hernandez, and I'm a computer engineering student at Fresno State University. And today, along with my partner Devin Cornell, we're going to be talking about our ECE 120 lab final project. So let's jump right in. For our final project, we decided to use a PIC 16 F84A to create a digital version of Hangman using an LCD display. So here's a picture of our circuit. As you can see, there's a total of 10 pins running from the PIC to our LCD screen, as well as 2 push buttons which will act as user input. So now that you know what the project is, I'm going to hand it over to Devin, and he's going to do a demonstration of our project so you can see how it works.
So we're going to demonstrate our final project. For this course we used a PIC 16 F84A, which we have mounted onto a trainer board right here. On this trainer board we also have a breadboard which we've connected push buttons to communicate with the PIC. We also have 10 pins leading to an LCD screen, and through all this we're able to create a project. So we're going to demonstrate it. First we're going to reset the code and we can jump into it. So it prompts you with enter a word using top push button to cycle through letters, bottom to confirm. Character is a backspace, there's a space character after Z, and a period at the end of the word to finish. So what happens is player 1 is going to enter in a word using the push buttons we have on the breadboard. The top one, you push it, it's going to cycle through the characters every time you push it, and this is how you're going to select which letter you want to use. So once you get a letter that you want to use, you just hit the bottom one below it to confirm that letter. So let's just spell a simple word, where it's just spell the word maybe land. So let's say you get LA, and let's say you put in a C accidentally. The first character is we programmed to be a backspace. So if you hit confirm on that character, it will backspace, so allowing you to increase the accuracy of your word. So let's just go over to land. We're going to go to LAN, go over to D. I missed this. So we can cycle through all the way just to make sure it cycles. Goes back to the top. So land, and then you finish it with a period. So you just hit confirm, and then next pumps up the screen for player 2. So player 2 can see that there are 4 letters he needs to guess. Over here it has his current guess, and over here it has his life. So the controls are the same. So the top push button is going to cycle through his guess letters. So let's say he guesses the letter H. Confirms on that, you see that it pops up on the bottom here, all your guesses, and it will decrement his life if he guesses it wrong. So let's say now he goes over to L and guesses L. You can see that it pops up on the screen, displays down here, and does not decrement his life. So we can go over and guess the word land, so I'm going to confirm on the A. Now I'm going to go over to N. And lastly, D. So let's just say you repeat one of your guesses before, so we can go over and try to do another N. Hit confirm. You can see that decremented the life one more. So don't re-guess your wrong ones. I missed D again, so I'm going to go all the way around. It cycles back. D, confirm on the D. Once you guess the word, it prompts with you win. So we're going to reset it again to show the case if you lose. So prompts go over again. So let's do another word. Let's just do C. We can just pick something random. Just do that. Okay, and then we'll confirm that word. So let's say you guess, we're going to go over and guess F, wrong, decrement, guess A, confirm, B, confirm, G. Keep guessing the wrong ones. You can go over to Z. And lastly, if you guess the last one, decrements your life to 0, and then prompts you with the game over.
Okay, now that you've seen a demonstration of our Hangman game, I'm going to run through the assembly code, and try and explain each section so that you have a better understanding of how our project worked. So to start, we have some initializations, just clearing flags that we're going to use in this code, and also clearing out the space in memory where we're going to store our word. Just make sure that our pick is ready to go and be used. Next, we have a section here that sets up our input and output ports correctly, so we're using the right ports. And then after that, we have the LCD initialization. So this table here is called, each one of these values in this table is an instruction which is sent to the LCD. All these instructions are necessary to make the LCD function correctly. So once those have been executed, we move on and we're going to display a message for the users. So this message here will be displayed on the LCD, and these are just instructions on how to play the game. So that is outputted through the LCD, and then some delays are called here, which give you time to read the LCD, and then another message is displayed, also still explaining how to play the game. So once those have been displayed, we're gonna move into a loop which is waiting for input from the first player, which is here. So this loop, the first thing it does is checks this flag here. This flag lets us know if it's player two's turn, if the word has already been fully entered. And so if it hasn't, it's going to go down here and it's going to check both of the push buttons. And based on the push button, it's either going to cycle through letters or confirm that letter. So first, let's check out the cycling. So this section of code is necessary here because of the strange cycle pattern that we have. By using the backspace character that we're using, the period and the space, we need to make sure that we're going to the right next letter. So that's all this does. It checks the current letter that you're on and make sure that when you press the button, the next correct letter is displayed on the LCD. So that's what this section of code does here. This code actually writes that. This section here actually writes that to the LCD. So the next section is if the confirm button is pressed. So that's what this does. The first thing it does is there's two special cases. We have a space and a period, which have a special function, which aren't letters. So it needs to check if it was a backspace or a period, which is what this does. And if it isn't a backspace or a period, it's just a letter or a space, then we need to write that to the LCD. So let's look at that first. If it is just a letter, we're going to write that letter to the LCD. So the first thing it does is, since we can only have a maximum of 20 letters in our word, make sure that the word has less than 20 characters in it already. And so if it does, it moves on. And these next sections here increment our counts. Then we're keeping track of how many letters are in the word, how many characters total are in the word, so that just increments those counts. Next, the letter is stored into the PIC's memory, so that later we can see if the letters are guessed correctly for player 2. Also, it will write the letter to the LCD screen, and then write a backspace to the LCD screen, because the backspace is going to be our prompt for the next letter. That's where the cycle starts, is on backspace. So that's the case if it's a letter, and the case that if a backspace is confirmed is here. So if a backspace is confirmed, the first thing it needs to do is make sure that there's actually a letter to backspace. So this just makes sure that there's actual letter to backspace. And so then after that, we take care of our counts. We make sure that they're decremented. And then we're going to write a space, which is what this section here does. We're going to write a space to the LCD screen over the backspace character that is currently displayed. So that'll be erased. And then we're going to write a backspace which is here, over the letter before that, and that'll effectively backspace the character. And then this section here deletes the letter from memory, so that way it's backspaced in memory as well, not just on the LCD screen. And this section here simply debounces the button, waiting for it to be unpressed, and once it is, it returns back, waiting for the next button press. So this section here is if a period is confirmed. So all of this done is make sure that there's been at least one letter entered, which is what this section does here, and then sets the flag that we were talking about earlier, this flag here. So when it goes back to that waiting loop, the flag is going to be set, and it's going to know that a period's been entered and the word has been confirmed, and we're ready for the next step of the game. So this next section is if the flag has been set and it's now player's 2 turn, the word has been entered, and so this just does some initializations for that, because there's a special interface that you've seen in Devin's video, so we need to set that interface up. So the first thing that it does is clear the screen, which is what this section here does. Clears the LCD, and then it's going to it's going to cycle through this place in memory where we stored the word, and for every time that there's a letter there, it's going to write an underscore on the screen. And if it was a space, it's going to write a space. So here it checks to see if it's a space, and if it's a space, it's write a space. If not, then it's going to write an underscore. So this is these subroutines here: write a space to the LCD and write an underscore. So that's all that section does, is it checks memory and puts spaces and underscores in the correct place, so that player 2 can guess the word and see how many letters are in the word and so forth. Next, we needed to finish our interface. So if you remember from Devin's video, there was on the top line a guess written. So that's what this does. It simply writes guess on the LCD screen on the top line, and then immediately after that it writes life, so that so these words are on the LCD to help player 2 know what he's guessing and how many guesses he has left. And so that's the first line. The interface for the first line's finished, so we're going to move on to the second line down here. And so on the second line displays already guessed letters, your current guess, and the amount of guesses you have left. So the first 30 spaces are reserved for already guessed letters. So so that's why we have a 30 here, and it's gonna move over 30 spaces and write and display in A, which is what's here, and that's gonna serve as our current guess letter A, and that can be cycled through later. And then after that, a 9 is written on the screen, and that's because you start with 9 lives, and then the life count is updated to be 9. So you're starting with 9 lives, and the A is displayed to cycle through. So now we're going to move into another loop here, another wait loop, waiting for player 2 to enter some push buttons. So this cycle is a little bit different because you do not have a backspace or period or space characters. So there's only one check here on a Z. We need to make sure that it goes back to A. So that's our cycle there, and then this is updating the LCD to make sure the current letters displayed. So here this is confirming a letter, and so the first thing that it does is it goes through all of the letters that we've stored in memory and checks them against the currently guessed letter. So if a correct letter has been encountered, then it's going to increment. It's going to call this function here, right here. And so once this subroutine is called, this one is going to write that letter to the LCD in the correct place. So that'll be your current guess. That's so it displays all of the guessed letters on the bottom, and then it's going to change this flag, and this flag gonna let us know later if we need to lose life on an incorrect guess or not lose life for a correct guess. So this sets that flag so that it's a correct guess and we're not going to lose life later. And then that increments this right C variable here, and this is keeping track of how many correct guesses player 2 has had. And so when this number here matches the amount of letters in the word, then that's our win condition here, which is checked right here. So if that life count, or if that correct count reaches the amount of letters in the word, then you win. And then this win is goes to a subroutine which simply displays you win on the screen, and then the program ends. So then, and that's if you get a correct letter guessed. And if it's not a correct letter, it runs through all of the letters we've saved in memory and doesn't find a match. So this flag here is never set, which means that when we get down into this section here, that you're going to lose life. So first of all, this section here updates your life, so it needs to make sure it's in the correct place on the LCD where your life total is shown. So that's what this section here does. It simply gets you to the right place in the LCD. And then here we're checking that flag, and if that flag is set, then you're gonna is not set, then you're gonna lose life. So that happens on incorrect guesses because the flag's never set. And then of course that new total is displayed on the LCD, and then the flag is cleared for next time for the next letter. So down here, this is going to show all of your already guessed letters, incorrect and incorrect, on the LCD on the bottom left corner. So first, this section here simply gets to the correct place for that letter based on its ASCII value. So it's, A is going to be in the very left, and then all the way down to Z. So then this section here actually displays that letter. And then it goes down to go back and write an A back to your guess. And so that way when we return to our wait loop, A is sitting there again to be cycled through. And lastly, it checks your life total. So if your life total is 0, then that means you've lost, and so it's going to go to the game over, and so that simply displays game over, and that's here. So once you've run out of lives, it simply displays game over on the LCD screen and waits to be reset. And down here is the same thing for a win. So if you win, then you win is displayed on the LCD. And that's all of our code, pretty much. Down here are some delays, software delays that we've written. Make sure we get the correct time. This is a enable toggle for the LCD so that it can get its messages. And that's it. And that's our Hangman Project. This is a slide showing which partner did what within the project. I personally wrote the code segment for the player 2 portion of the game. I also did this PowerPoint and the code analysis video that you just saw. Devin wrote most of the code for the player 1 part of the game and also did all of the interface design, so how the game should look. And he also did the project demonstration video, which you also saw earlier. So again, this is Isaiah Hernandez, and speaking from our partner Devin Cornell, we thank you for watching and hope you have a nice day.